Hey guys, welcome to lesson 2.8, solving polynomial equations, part 2. Now normally in class I would get you guys to do a quick warm-up question, but because we are doing video format, what I'd like for you guys to do is try this warm-up question on your own, work through it. I will let you know right now that when you go ahead and solve for the roots, you should get that x equals -1, and your other two roots should be -4 plus or minus root 11. And if you aren't getting those answers, please make sure that you let me know, and that way we can go ahead and discuss it in class. So we'll go ahead and move on to some of the tougher solving polynomial equation examples. The first one we'll start off with is example A here, and it does look a little bit daunting because you have some couple of binomials inside the bracket there, the x squared minus 2x, but this really can be solved quite easily if you do a quick substitution. So notice that inside both of these brackets you have the same binomial, x squared minus 2x. So what we'll do in this case is say let w equal x squared minus 2x. And now what happens at this point is that the question now becomes w squared minus 11w and then plus 24. This trinomial is actually quite easy. All you have to do is think of two numbers that multiply to 24 and add to -11, which would be -8 and -3. So when we go ahead and factor this equation here, I would say that we would have w minus 8, w minus 3, and set that equal to 0. Now you need to remember that w was never part of the question. W was a placeholder that you created, so make sure that you go back and sub in what w is. So this question actually becomes x squared minus 2x minus 8, and then x squared minus 2x minus 3. So what actually happens here is now we have two trinomials inside the bracket, which are both factorable. So we are going to say, okay, two numbers that multiply to -8 and add to -2, well, those two numbers are actually -4 and +2. And then think of two numbers that multiply to -3 and add it to -2. Those two numbers are going to be x minus 3 and then x plus 1. And now, since we are fully factored on that left-hand side of the equal sign, we can go ahead and state our roots. So we have x equals 4, x equals 2, x equals +3, and finally x equals -1. So remember, you're letting each one of these brackets, you're setting them equal to 0, and then you're solving for x. Alright, we'll move on to example B here. Now, in example B, we do have a quartic function. Now, as I said in class, before you go ahead and dive right into doing factor theorem, which can be a lengthy process, especially for a quartic, you need to recognize that we only have three terms here. And very conveniently, we are missing the x cubed term and the x term. So what we're left with is x to the power 4 minus 5x squared plus 4. Now, we do have a trinomial that looks very similar to a simple trinomial. So if you would like to do a quick substitution, you can say that some other variable like w, set that equal to x squared. So I'll start off, I'll write this equation actually backwards. So we have the plus 4. The substitution works nicely over here because I'm just going to say that this is minus 5w. Now if you think about it, well, if I take w and I square it, that's the same thing as saying the x squared, which represents w, is squared. So w squared equals x to the power 4. And that's exactly what we want over here. So this is really w squared. So we are left with a trinomial that we are all very used to factoring. we're looking for two numbers that multiply to 4 and add to -5. Those two numbers are w minus 4 and then w minus 1. And again, similar to the last question, w was a placeholder that you created, so we are going to replace that with our original statement here that w equals x squared. So this really is x squared minus 4 and x squared minus 1. Now, if you can notice that this is almost like a simple trinomial and want to go ahead and go straight to the factoring, you're more than welcome to do so. You don't have to do the substitution. But in any case, the important part is that you actually get to this line here and notice that we actually have two binomials that are difference of squares. So if I were going to factor a little bit more, I would say that this is x plus 2 and x minus 2, and then x plus 1 and x minus 1. And again, we're fully factored on the left side, so I'm going to set each bracket equal to 0 and solve. So with the first two brackets, I know that x can be either positive or -2, and looking at the last two brackets, x is equal to either positive or -1. So we do have 4 distinct roots there. Alright, we'll move on to example C. Alright, in example C, we notice that we have two terms here, and both of these terms are actually perfect squares. So the 36 is actually a perfect square as well. And these two terms are separated by a minus sign. So that tells me that I can do difference of squares here. Now, whether you're comfortable enough to do difference of squares right away, or whether you want to do a substitution, that is totally up to you. I'll do the substitution just to show you how it's done again. So I'm going to create some variable, and I'm going to let that equal the binomial inside that bracket there. So this is x squared minus 5x. And then my equation now becomes w squared minus 36. So because I've already noticed that this is a difference of squares, I can factor by saying x plus 6, and then w plus 6 and w minus 6. And again, because we created this placeholder, we need to replace it with the original statement being x squared minus 5x. And again, x squared minus 5x. And hopefully what we notice now is that inside each of these brackets, we have trinomials that are that we're able to factor further. So looking at this first bracket, I want to find two numbers that multiply to 6 and add to -5. Those two numbers are going to be -2 and -3. And then finally, we want to find two numbers that this time multiply to -6 and add to -5. And those two numbers would be x minus 6, and then we have an x plus 1. Alright, so from this, because we're fully factored on the left side of the equal sign, we can state our roots. Our roots being x equals +2, +3, a +6, and then finally a -1. So the question states that the volume of the rectangular prism is 42 centimeters cubed. We want to find the value of x, and then we want to find the dimensions of the prism. So we'll start off with the information that's given to us. We are told that the volume of this particular prism is 42 centimeters cubed. So we're dealing with volume here. Remember that the formula for volume is length times width and then times height. And basically all we're going to do now that we have the formula is sub in what we know. We know the volume is 42, and we're given length, width, and height in the diagram here. So we have x minus 1 times x plus 3, and then times x minus 2. Remember that in order to solve for your roots, one side of your equation must equal 0. So that tells me, okay, I'm going to move that 42 to the other side. Now, the problem is, and a mistake that I notice that happens a lot on tests, is that students will say, okay, the roots are 1, -3, and +2, and then they do something with the 42. The fact is that the right side is not fully factored, and when it's not fully factored, you can't state the roots. So what we're going to have to do here is expand and then collect like terms and then try to refactor. I will start off by, let's say, expanding these last two. So x plus 3 times x minus 2. That's what I'll be focusing on. So x times x times negative 2 plus 3 times x actually gives me just x. And then finally 3 times negative 2 gives me negative 6. Okay, notice that this 42 I'm not going to touch until I've expanded all of the brackets. So I'm going to take this x minus 1 and distribute it into the second bracket here. So x times x squared, and then x times x, and then x times negative 6, and then finally negative 1 times the rest of this bracket, and then minus 42. So because we're expanded now, I can collect like terms and even collect that negative 42 inside our expression. So we only have one x cubed term. We have x squared minus x squared. So those actually cancel each other out. We don't need to worry about those. We have negative 6x minus x. So that is a negative 7x. And then finally the constants, we have a 6 and a negative 42. Altogether that gives us minus 36. Okay, so now that we are fully expanded, now that we've fully expanded our equation, we can go ahead and look at trying to factor what is on the right side of the equal sign there, the x cubed minus 7x minus 36. So taking a look at this, I see that there's no common factor. I see that I can't really do any kind of factor by grouping. There are 3 terms, but it's not a simple trinomial because it doesn't go x squared and then x. So really what we're stuck doing here is having to deal with the factor theorem. Okay, and using that hopefully shortcut that I taught you guys on your calculator, you'll notice that when you try and sub in some test roots, hopefully you'll notice that f at 4 works out for you. Okay, so when you sub in 4 into the equation, you should get a remainder of 0. So that does tell you that x minus 4 is a factor. And then when we go ahead and do the synthetic division on what we're given here, so there's our test root of 4, and then our coefficients, I have 1x cubed, I have 0x squared, that's important. We have minus 7x, and then negative 36. So I drop down the first term, and I multiply, I add up the 0 and the 4, I multiply, I add up negative 7 and 16, and then I multiply, and we get 36, and finally add them up. So notice that I did get a remainder of 0. So our function, which was x cubed minus 7x minus 36, has now been broken down into x minus 4, and then x squared plus 4x, and then plus 9. So we go ahead and try to factor this simple trinomial, and we notice that there are no two numbers that multiply to 9 and add to 4. So what we're going to be stuck doing is using the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4 times a, so 1, and times c, which is 9. And then altogether, 4 times a times c gives you 36. All over 2a, so just 2. Cleaning up inside the square root, we actually have negative 20 all over 2. Now, because this is an application question asking you to solve for dimensions of a prism, right away we'll notice that because we have a negative inside our root sign, that we're actually going to get some complex roots. If the question just simply said solve this polynomial equation, then I want you to go ahead and finish off this and simplify the complex root. However, because x here represents some sort of measurement, we can actually ignore the complex root and just say that the only root is at x equals 4. Okay, so recall that the question did ask us not only to solve for x, but to find the dimensions. So the length given to us above was x plus 3. And when you sub in 4, we know that the length of a rectangular prism is actually 7 centimeters. The width was given to us as x minus 2. So calculating the width, we get 2 centimeters. And then finally, the height was given to us as x minus 1. Okay, so not only did we solve for x, but we also stated the dimensions. And that is it for today's lesson. As always, if you have any questions, please make sure you ask me next time in class. Take care, guys.